Good morning everybody. In this video we are going to study about the fundamentals of solar photovoltaic conversion solar cells from the subject renewable energy technologies. I am David, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. A photovoltaic cell, it is PV cell, commonly called a solar cell, is a non-mechanical device that converts sunlight directly into the electricity. Some PV cells can convert artificial light to the electricity. Sunlight is composed of photons or particles of solar energy. These photons contain varying amounts of energy that correspond to the different wavelengths of the solar spectrum. A PV cell is made of semiconductor material. Which photons strike a PV cell, they may reflect off the cell, pass through the cell, or be absorbed by the semiconductor material. Only the absorbed photons provide energy to generate electricity. When the semiconductor material absorbs enough sunlight, electrons are dislodged from the material atoms. Special treatment of the material surface during manufacturing makes the front surface of the cell more receptive to the dislodged or free electrons, so that the electrons naturally migrate to the surface of the cell. The flow of electricity in a solar cell. The movement of electrons, each carrying a negative charge toward the front surface of the solar photovoltaic cell, creates an imbalance of electrical charge between the cell's front and back surfaces. This imbalance in turn creates a voltage potential like a negative and positive terminals of a battery. Electrical conductors on the cell absorb the electrons. When the conductors are connected in an electrical circuit to an external load, such as a battery, electricity flows through the circuit. This is the construction of photovoltaic cell. So the components are transitive negative terminal, positive terminal, glass, P and N type layer, then junction. Solar cells. Solar cells can convert the energy of sunlight directly into the electricity. Consumer appliances used to provide services such as lighting, water pumping, refrigeration, telecommunications, and television can be run from the photovoltaic electricity. Solar cells rely on the quantum mechanical process known as the photovoltaic effect to produce electricity. A typical solar cell consists of a p-n junction formed in a semiconductor material similar to a diode. The figure shows a schematic diagram of the cross section through the crystalline solar cell. It consists of a 0.2 to 0.3 mm thick monocrystalline or polycrystalline silicon wafer having two layers with different electrical properties formed by doping it with other impurities. An electrical field is established at the junction between the negatively doped and positively doped silicon layers. If light is incident on the solar cell, the energy from the light creates free charge carriers which are separated by the electrical field. An electrical voltage is generated at the external contacts so that current can flow when a load is connected. The photo current which is internally generated in the solar cell is proportional to the radiation intensity. So this diagram shows the clear components of solar cell. A simplified equivalent circuit of a solar cell consists of a solar source in parallel with a diode, which is shown in figure. A variable resistor is connected to the solar cell generator as a load. When the terminals are short circuited, the output voltage also the voltage across the diode are both zero. The entire photo current generated by the solar radiation then flows to the output. The solar cell current has its maximum if the load resistance is increased which results in an increasing voltage across the PN junction of the diode. The portion of the current flows through the diode and the output current decreases by the same amount. When the load resistor is open circuited, the output current is zero and the entire photo current flows through the diode. Thank you.